Hey, Kiwi Decoders! Michael L. Perry here. I'm getting a severe sense of deja vu because you know what? It's Groundhog Day! It's like I've done this before. Really strange. Groundhog Day means groundhog coding, and groundhog coding means that you write some code and then at the end you throw it all away. You get to keep what you've learned, but you don't get to keep any of the code. That's what we're going to be doing. We're going to be trying to create a full application from scratch using Jinaga, and we are going to throw that entire application away when we're finished. Last time on Groundhog Coding, we used Postgres. That was before. No, last time we used Passport. That's the one. I knew it was something that started with a P. Passport in order to authenticate a user, and we were using Twitter authentication. Now, I took what I learned from that. I didn't take any of the code. I threw the code away. If you watch the video to the end, you notice that I did that. But I took what I learned from that process, and I rolled it into the Jinaga starter. So now the starter for Typescript includes authenticating with Passport, specifically with the Twitter Passport strategy. And so that's one of the rules of Groundhog Coding. We get to use anything that's publicly available, and that includes starter kits. So let's switch on over to the code. We have here jinaga.com. If we go to the documentation, we will see starter kits right here. We can use the Typescript starter kit or the Typescript starter kit with React. Let's go ahead and use that one. And you'll see this is exporting a bunch of code from Subversion. So I'm just going to come in here and I will paste that code in, or that command in. Come on, copy, paste. There we go. And we're not building something called My Application. We're building something called Yaka, yet another chat app. One of these days, we'll actually finish Yaka. But until then, that's what we're trying to do. We're trying to build an application from scratch using this starter kit. So down comes all of that code. Let me show you what that looks like. Here's Visual Studio Code. We've now opened up Yaka. And we can see that we've got a package JSON. There's a nice little README that tells you exactly how to do that. So we've brought down the code. And so we've gone that far. Now we need to do an npm install. So npm install, let that start going. Okay, that's coming down. The next thing is we need to do our database setup. So that means we jump into Postgres. Let me go ahead and create another tab here, and we do our psql SQL, and then -h for the host shall be localhost. And rather than run this file right now, first I need to -u Postgres, the Postgres database. I need to go up there and need to create a brand new database called Yaka. Okay, creating the database. I really should put those instructions in the README. This has got a link to the full instructions on jinaga.com, but you might not want to read those. So there's our database. And now I can Control D to log out. And then I actually run this with Yaka. So that's the name of the database I just created. And so we've just run let's see, node modules. Okay, this is still running. We need to install the node modules, and that pulls in things like node modules Jinaga, which has the script that I need to run. So when this is finished, then we'll be able to complete the database setup. There we go. Now we can switch back and we can run the script. Okay, we have created the Yaka database. Now, to build, npm run build. All right, we Control D, get rid of that terminal. Now we're back to one terminal. npm run build. And it's building, and we should see a dist folder show up over here. That will be our distribution. Any moment now. There it is. So we've got our server.js. That's our server-side code. We also have scripts, which contains all of our client-side code. So we've got index and login. So now we have two client-side scripts. So if we take a look here, client, we've got index tsx and login ts. tsx because this is the React starter kit. So we're using some React here. So that generates all that. And then in views, it gives us our index HTML and our login HTML, and it puts the right script tag in there. This is Webpack doing all that fun stuff for us. You just gotta love Webpack. It's pretty awesome. Okay, so we have built. Now we should be able to do an npm start, and that will start up the application exactly as we've just built it. So it's running at localhost 8080. Control click on that, and there we go. There's our little sign in with Twitter. Oh, there's something I forgot to do before I did that. Let's switch back here. Kill that. There is also right here when we configured Jinaga, right there we need to tell it which database we're talking about. We're talking about the Yaka database. Okay, so we fixed that connection string. Now it's connecting to the correct database. The My Application database does happen to be on this machine, and so that's why I didn't get any kind of error. But because we created the database Yaka, I really want that to be the one I use here. I'm also going to do an npm run dev. So you'll see here that we've got a few scripts. One is called start. That's the one that we just ran before. That ran node. Dev runs Webpack watch, and it runs nodemon. So if anything changes, it'll reload and restart the application. So this gives us a really good developer experience. So we've got dev running. We've got our application configured to hit the right database. And I go to localhost 8080. All right, here's my login page, sign in with Twitter. And because I've already set up the Twitter credentials on this machine, and they're part of the environment variable, so they're not part of the code that I'm building, then they get picked up, and I'm logged into Twitter. And now here I'm back on, and I'm doing my old visitor counter. So all of this is working pretty well. Let's take a look at what it means to be logged in a Jinaga application. So I'll ignore the server for right now. Let's look just at the client. So at the client, we've got our index tsx. So we've got an application. We're putting in the application host. It's inside. It's just the div inside of the index HTML. Let's dive into the app. So the app has a visit counter for this new domain at my application. In fact, I could say, hey, this is the domain Yaka. So while here we're counting up the visits to my application, if I change this. We'll see it rebuild stuff. Stuff is rebuilt. And now when I refresh, we're going to start back over at 1. Are we not? Are we not? Interesting. Well, that's a nice little bug. Okay, let's keep drilling down and see what's going on here. So we've got our domain that's coming in as one of our props. So we're setting that. We're also setting the state to visits 0. And then we are, I think I know precisely what's going on. This is a Jinaga bug that I do need to fix. But let's go through this real quick. So when the component is finished mounting, then we're going to call login. So this is an async function. We're going to await the results. And when we get the results back, it's going to have something called user fact and something else called profile. User fact is a fact that represents the user. We're going to take a look at what the user fact actually looks like. We're destructuring this into user as the name that we want to use there, and it's going to be of type user. So here we're just casting that to a user. That's all that's really doing. And so that's coming in with the type equal to jinaga.user, and it's got a public key, which is a string. So, oops, physics counter. So that is coming in now as this user object. So that means user is of type user. And we're also getting a profile. And profile is extra information that's coming from our identity provider. So in this case, the profile contains the name of the person that logged in with Twitter. It's really just their Twitter handle is all that contains. If we take a look at profile here, we can see that it's got a display name. So that's the only thing that's getting set up there. Just copying that display name in. All of that is configured as part of the code that's in this starter kit. So if you need to change it, you can change it. But that code is set up right here with authentication. So in here, I am okay, actually it's in the authentication strategy for Twitter. So yeah, right here is where we pull information out of the Twitter callback and we put that into profile. So we're actually getting username and name as well. But the data type of profile, let's come back here. Yeah, the data type of profile here that's exposed from Jinaga just has display name. So this is really just the type checking is saying, well, display name is the part that's on the contract. But if I needed to grab name off of there, I should be able to find that too. So let's walk through this in a little bit, but the important thing is that we are logging in and we're getting a fact that represents the user. I want to be able to see what that fact is. So let's flip back over here and see if we can solve this problem. And I'm not seeing any errors happening here, which is what I thought that I would see if we were running into this particular Jinaga bug. But let me just show you what's coming back from login. So we call async login, so that makes the login call to the server, and we get back a user fact. So here's our user fact. It has the type jinaga.user, just like we saw in the type that we were declaring inside of our own code. It has a hash, like all of these that get exchanged have a hash, but right here, fields, it contains this public key. Where did that public key come from? That public key was generated as part of a key pair that Jinaga generated for me whenever I logged in with Twitter. and it stored that inside of the database. So if I were to come back here, let's go ahead and open up another terminal again. That way I can do pgsql or psql PostgreSQL host localhost user Postgres, and I want the Yaka database. All right, now I can do a select star from public.user. And here it is. Here is the user record that was just created. And so you can see there is the public key, and there is also the private key. Because of the output, they're kind of intermingled there, but there is a key pair. Now, of course, I'm not going to be using this public and private key for anything else, so feel free to copy that. You'll never see that again. But all of the authentication that's happening inside of Jinaga is happening using this public key. Authorization, I should say. So, so the public key identifies the user, and the private key is used to keep track of what that user actually did. So we can sign things with their private key. It's really cool. But all that is kept in there. What you have in this user is just this guy's public key. And that's it. Okay, so now we're doing a query, getting back no results. That's a query for, this is digging in a bit deeper than you might ordinarily want to, but we're starting from the domain, and we are querying for application visits. And here we're starting from the Jinaga user. So there's the user, that particular hash that was computed for that user, and we're querying for the user's name. All right, then we want to load in the username, and here we have Jinaga user, the name as the fields Michael L. Perry. So that's the part of the code that we're about to see, is that it found that on my Twitter login and it attached that to the Jinaga user. This save right here, we're trying to save the visit for this user. And all of that looks great. So why is it not showing up? Interesting. So record the user's visit, and then we watch. And when we see a visit, we count it. Count visits sets the state to visits +1, and it renders if visits is not 0. So it looks like that should have worked. Let's hit a breakpoint, shall we? If we take a look at this Webpack thing here, this is the browser decomposing the package that Webpack put together. This is really cool. So one bundle, lots of different files, the browser can take it apart and it can show you these are all the files that came from the build folder, the source folder. We've got node modules, and then we've got the source right there. Under node modules, we'll see a whole bunch of things, including Jinaga. So all of the Jinaga source code is right here, should you want to peruse that. But that's not what we're looking for right now. What we're looking for is in source client, we have components, and we've got visit counter TSX. And yep, here's visit counter TSX. Looks just like this one. It's the same file. But the browser doesn't know TSX. How is this happening? This is happening because of source maps. Webpack, source maps, Typescript. That's so cool. All right. So after component did mount, we run this async function, and when you're finished, we catch that So this guy right here, right there, that should happen even before the async function has finished, and we should go ahead and start our watch from this domain, looking for visits in that domain. So then after we hit a visit, we should come down here and count the visit. Let's refresh that and see what's going on. All right, first breakpoint is hit. Great. The domain is equal to identifier Yaka in my application domain. Fantastic. All right. And this right here is where we're about to... there's the problem. There's the problem. Do you see the problem? Do you see the problem? Silly, silly me. The problem is I created a brand new domain here rather than using the one that was passed in as a prop. And so the domain that I'm visiting is my application, and the domain that I am watching is Yaka. It's Groundhog Day. Woohoo! All right. Very good. Very good. We did a little bit of debugging. That's kind of awesome. All right. Let's go ahead and change this. So rather than domain like this, this is this.props.domain. Boom. Record the user's visit using the domain that's coming in through the props. All of this means nothing because it's not actually part of Yaka, but I want to see this work properly. So let's flip on over there. We should have had some rebuild action happening, and refresh. And now we're visitor number 1 on the Yaka domain. Perfect. Okay. Since we're in here, we can do a little bit of debugging and see what's going on. So when the component did mount, we call login asynchronously, and we get back the user, which is public key, that big long public key, and the type Jinaga user. So the user is getting set up. That's perfect. Profile is coming in, and we've got display name and we've got username. Apparently name didn't have a value, so it didn't get set. I'm not sure why. But, so as you can see, display name is not my real name, it's just my handle. So that's fine, we're just going to use that. Now what's happening here? This is interesting stuff. The next thing that we're going to do is we're going to query for the user's current name. So we're going to query starting from the user, that's this guy with the public key, for username for the user. What's all that? Here, let me flip over here so we can look through that code real quick. So query this user for usernames for this user. And now you can already see that that function. Let me go ahead and dive in there. I control clicked so I can dive in. We can see what this template function is doing. This is a template function that will match a username. I'm just reading it right there. It will match a username where the type is username type, and the user is you, is this guy. Not you, me, you. The letter U. Where the user is you. So it's going to match any username fact that looks like that. So we've got the type username and we've got you. Such that, so this is going to filter those such that the username is current. What does that mean? It's right there. Username is current. So a username is current if there does not exist a username that says the prior includes this guy's username. Wait a minute, what does that mean? That makes no sense. I'll tell you what that means. What that means is that we don't have a successor. We don't have a new username that's taken this one's place. So my name, Michael L. Perry. If I change my Twitter handle, which I couldn't and still be the same user, but supposing I could, then we would get a brand new username where prior points to this one. Because that username exists, pointing back to this one, then this one is no longer current. So that's what's happening there. So we're going to query for the names of that user. Let me go ahead and hit F10 so we can step over that. Come on, F10. That's too far. That's weird. Okay. So now we've stepped over and we have names. That's just an array of one name. So here is my fact. That is the value Michael L. Perry for the user, the guy with this public key. And the type is my application user name. Prior is an empty array. So if I wanted to change my name, I would create a new fact, and this fact would be inside of the array for the new one. So each fact points back to the prior one, the one that it's replacing. Prior is in an array because the first one is going to be empty. There is nothing prior. And later when we talk about conflict resolution, when you resolve a conflict, you're going to have multiple priors. It's just like a get merge. So if all that makes sense to you, great, you're ahead of the game. For right now, all we're doing here is we are getting the user's current names. If there's not exactly one, and right now there is one, so we're good, or the one that we get is not the same as our display name, then we're going to pop in here and create a brand new fact, where the names that we just queried are the priors, and we're going to create a brand new one. But, as it turns out, F10, are you going to do it? Weird. Weird. It's going to skip over that if, because we have one and it matches. So we're good. So now all we're going to do is record our visit. So we record our visit, and no longer are we visitor number 1. After we record the visit, we will see that we are visitor number 2. Yay. Okay, so by recording the visit, we sent it to the server, and we made this watch happen. Remember, this watch was set up before we, outside of this async. So it happened before we finished all of this stuff in here. So that watch already existed, and that way when I record a brand new visit, the watch gets fired, and the visit gets updated. So all that's great, all that is fantastic, but that's not the Yaka application. Let's build Yaka. Okay, so here's our model. We're going to keep the user model. So that's our user that we were just talking about. That's the user name, which records the name of the user and gives you the template functions you need in order to query for their current name. And we've also got this authorize user. We're going to talk about authorize later. And the bug that I'm referring to that we might need to, right here we're working around that bug by not setting the authorization configuration. So once we get that bug fixed, then we can turn that on. We'll talk about all that. But that's not what we're going to be talking about today. Today, we are talking about building Yaka. So Yaka is not about visits. Let's go ahead and get rid of visits. Boom. Yaka is not about, everything's blowing up. Yaka is not about visit counters. Get rid of that. Yaka does have an app, sure. But the app is not visit counters. It's yet another chat application. yet another chat. And so we are going to show all of the messages in a channel. So this is going to be a channel. Channel messages is what I'll call it. I'll call it channel messages. So rather than domain, this is going to be channel. And I want that to be a new channel. And the channel we shall call general. Okay. None of these things exist. Let's go ahead and create them. So inside of model, that's where I'm going to want to create this channel concept. So let's create a new class, a new file called channel.ts. So this is going to export class channel. And we want this to be a Jinaga type. So this is the pattern that I like to use in Typescript for Jinaga types. I start with a static type, and that's going to be a string. So we'll call this yaka.channel. And then we're going to set type equal to channel.type. So now we've got an instance variable that's of type. And then we give it a constructor, and there we specify all the other stuff. So these are public. So I've got a name, which is a string. Okay, there we have our first class. So that means in here I should be able to control space, and it's not coming in because it has to reach out in order to find shared. But then once we find shared, then we can go to model. Let's see, why are you not working? Shared. Okay, oh, that's because I am one level deeper, so // shared model channel. And so in there we go, there's my channel class that was exported. So create a new channel, and you can see if I hit Control Shift space, that's the name. So it's picking up the signature of the constructor. Perfect. Channel message. I want that to be another component. Let's create a new file here, channel message.tsx. And because this is a TSX, I need to import star as React from React. So I've got that. And now I can have my channel message. So let's go ahead and declare this one as a class. Export class channel message, and this extends react.component. Looks good. So we need a constructor which takes props, and I say super props. And then here I can set up some state. So this dot state is equal to something. So because we are in Typescript, we have an opportunity here to tell the React component the type of our props and the type of our state. Let's go ahead and define those. So I'm going to export a type called channel message props. And that's going to be right now equal to an empty object. And then I'll export another type called channel message state. And that's going to be this empty type here. That way I can say I'm going to use, let's put this on another line. Okay. Channel message props. Channel message state. There we go. Then I can say my constructor takes a channel message props. That's the type of props. And now it's not complaining that that's an implicit any. So we're passing that on to super, and super takes a channel message props because that's what I told it. And then state is a channel message state because that's what I told it. Okay, so we've got that started. Let's go ahead and do a render. So this is going to return, and we will just have a, let's do div for right now. Just so we can see something showing up on the screen. So we have our components. Come back here to the application. Now I can hit Control space, and it'll do the auto import from channel message. And there we go. And then Shift Alt O. Control Shift O? No, it is Shift Alt. Shift Alt O. Yeah. Just to make sure that all of these things are correct. So channel message. Aha! Aha! I'm trying to send in channel. That's not assignable. That's not part of props. So this is Typescript, making sure that I do all the right things correctly. So channel message props will take a channel, which is a type channel. And that is coming from, oh look, I figured that one out. Out, shared model channel. There we go. My channel is coming in. That is part of props. So now anytime I take a look at props, I should be able to see that it has a channel in it. So we're good there. So now it means this one's happy. Control Shift S, save everything. And now, hey, we're getting a lot of green, a little bit of yellow, some white, a little bit of gray. The point is, it compiled. It compiled. So that means I should be able to come over here, refresh the page, and now rather than being a visitor, it should bounce me over. Oh, all right. This is because the server is not compiling. Let me go ahead and show you. If I hit RS, oh, not in here. Down here, if I type RS and hit enter, that restarts NodeMon. And now we can see NodeMon is having trouble. And so it's crashing, it's stopping, and it's waiting for me to fix the problem before it tries again. The problem is that that the build failed. Well, okay. Does it tell me the build failure, or do I have to go search for it? I'm sure I have to go search for it. Okay, TS loader, index.js. Oh, I recognize this. This was a problem that I thought I fixed. Here in package.json, I'm doing dist server. Okay, well that's fine. So node modules. Oh, okay, I'm sorry. That's just the TS loader itself. Okay. No such file or directory model visit. There we go. There's the problem. We're trying to load a TypeScript file using the TS loader, and it cannot find shared module visit TS. And it is looking in server.js 332. Wow. Oh, that's the compiled code. All of that is coming from, so if I actually paid attention here to what Webpack is telling me, it's giving me the reason for that. right here, that's the client-side code. Scroll up a little bit more, and I'll find, here's some server-side code. No. Yeah, I'm sure that it's up there, but I'm also pretty sure I know where it is. If we take a look at the server-side code, so close down the client, so here's the server, right? We don't care about shared, just the server. Server TS. So we're just configuring authentication, configuring routes, configuring Jinaga. Let's look at configure authentication. No, actually, that's setting up Twitter authentication. Configure Jinaga. This is where it's going wrong, because here it's trying to authorize visit. It's trying to call that authorization function. That's commented out, so I'm not using it anyway. I'll just delete those lines. And we'll get to what those lines actually mean later. But now it rebuilds the server and it restarts, and now it's actually listening. F5. All right, here we go. Sign in with Twitter. Redirecting back. And yet another chat app. Here's the channel. Perfect. Most excellent. Let's get back to just this guy. Here's our Yaka channel. And now I want to see all of the messages in the channel. We did this before, didn't we? Well, that was a different Groundhog Day. Now it's this Groundhog Day. So that means that I want to set up a watch looking for all of the messages in the channel. And I do that when component did mount. So here I will say something like const w, just to hold on to it for a second, equal to j dot, ooh, where's j? I need j. Let's grab me some j. Import from // Jinaga config j. Perfect. All right. Might have been able to hit the control spacebar and import it that way. Give that a try. We'll do that next time. So I want to do j watch. What? Watch. j.watch. So where am I going to start? I'm going to start with the channel. So this.props.channel right there. And it knows that because I set up that type. So we're starting at the channel. Now we need to look for something related to that channel. So I do j.for, and now here I need to send in a template function. So I'm going to look for the messages in that channel. So I want it to look something like message.inChannel. So I want that to be a template function, which means I want message to be a fact. So let's hop down to, we don't need the server anymore, down to shared. In the model, I'm going to create a new, you know what, I'm going to just put that all inside of channel because they are so closely related. Export class message static. Type with a capital T is equal to Yaka message. So type is message.type. And then the constructor for a message. This will be in a channel. So we will capture that. the message will also have some text associated with it, right? So we're going to have the text of the message, which is a string. And what else is interesting about a message? You know, the sender. Sender shall be a user. All right? I'm just putting that in front of text because just by convention, I like to put all of the predecessors before the values. And both channel and sender are predecessors of a message. The message must be in the channel, so the channel must exist first. And the user must have signed up for the service before sending messages. So the user is the predecessor. So both of those are predecessors. And then I want to be able to say, first of all, control space, auto import from the shared model channel, message in channel. So let's create a template function. It's a static function in channel C. That is a channel. So this shall match return j.match. I'm going to match message. So the things that are matching are messages. I only have to say that because I'm in Typescript. If I were in regular old JavaScript, then I wouldn't have that type declaration there. But I'm matching messages where the type is equal to message.type. That I do need to say whether I'm in Jinaga, or Typescript or JavaScript. And the channel is what? C. That parameter right there. So I'm just going to match messages in this channel. Where is J? I don't know. I'm inside of shared, so that means when I import, I cannot go out and get to client in order to hit the Jinaga config, because on the server we don't have that. So in order to get access to J while I'm in shared, I just use Jinaga, and that gives me access to all of these types, Jinaga being one of them. I import Jinaga as J. And so that way I've got access to all of the statics, such as for and match, and not exists, and exists, and not. Okay. So with that, we are now looking for messages in the channel. Once we find them, what's going to happen? We're going to have a result added. Let's go ahead and set that up. We're going to have a result, which is a message. So just message, arrow, and then we want to call this dot add message. And we pass in message. Okay, add message doesn't exist yet. Well, let's create it. All right, so here is, I can make this private. So we're going to have a add message. It's going to take a message parameter, and this is going to do a this dot set state. And so I pass in a channel message state because that's what I told it. So so I'm going to give it an object, and I will start by doing a spread operator, this dot state, okay, which technically works. It's really just copying this dot state, so it's really having no effect. But now I can do additional things. So here I can also have messages, which is going to be some array. And that array is going to be this dot state dot messages. I'll use the spread operator on that. So now I've got all the messages that were in that array before, plus a brand new message. That one right there. Now, of course, this statement that messages, that's not part of channel message state. So, channel message state, let's add that. Messages, that is a message array. Okay. Now, we have our message array. We add our new message to it. Look at that. Look at that. It's helping me. It's saying, you know what? You forgot to initialize messages. So let's do that. Messages is an empty array to start with. That's the sort of bug there that had I not had Typescript helping me and to find that would have made it all the way into the browser, and I would have seen the error there. But here, I don't have to have that question. I know what the answer is before I get this far. So we refresh the page. We didn't see anything happen because there are no messages right now. We need to be able to add messages. Let's add messages. So underneath this div, well, we also didn't see messages because we're not rendering them out. Let's go ahead and render them out. So I will first of all create an unordered list. Okay, and then within this unordered list, I will start with this.state.messages, and then I can do a map. And now I pass in a callback function which takes a message. There's my message. And now I know message is a message, which means I can do stuff like this. So I want a span which contains the message.text. It's all right there. It's all right there. Okay, so we will render that out. That'll be inside of that UL. Oh, wait a minute, not a span. This is a list item. List item. There we go, because it's inside of the UL. It has to be an LI. That would be really cool. That would be really cool. If React would do this type checking when it's using TypeScript to know that you have to have an LI inside of a UL. That would just be so cool. It would just help me out. And it would keep me from making the kind of mistake that I just made. And then you would know, if everything compiled, that you're going to generate valid HTML. That's valuable. I like that. But it doesn't do that. So now, right. Now what we're trying to do is add new messages. So that means that I need to have a form down here that will let me add those messages. And in that form, I will have a label for this is going to be message-text. I will call it message, and then what is this message-text you say? Label needs. Children for that's right. It's not called for. It's label for. What is it called? HTML4. That's it. HTML4. Because for is a reserved word. Okay, and then the input type is text ID. That's where we have our message text. The value is going to be equal to something in my state. State dot We'll call this message text. Starting to get a long line here, so let me break that. All right, so that's my value. And that's the input, okay? Which means I need message text to be part of the state. Let's go ahead and declare that. Message text is a string, which means that I need to initialize it here, so let me initialize it. Message text is a string. Okay, very good. So there's my input, and then here is my submit button. Submit, and the value shall be equal to send. Good. Good. I think that's good. All right, so now when you actually do send the form, then it's going to do something up here. On submit, this is what it's going to do. It's going to call this dot, what are you doing? This dot send message. Well, there is no send message. Let's do that. Private send message takes no proper parameters because we have the state. We know what the state is. So const message text is equal to this dot state dot message text. There we go. In fact, just to make things even better, I'm going to destructure this. All right, just to be fancy. What can I do? I can destructure message text. Ah, come on, help me out here. Control space, message text. Boom. Okay, destructuring that like a boss. All right, so I've got my message text. Now I need to j.fact. I need to say it is a fact. There is a new message. What is this message? Well, it's in this channel. Well, this dot props is where I keep my channel. Yep. And the sender is the user. Where's the user? I don't know. I'm going to need to grab the user. Let's see if we can find a nice place to grab the user. So put that on pause, come up here, and component didn't mount. That's where we're setting up our watch. Well, let's go ahead and grab the user. We want to await j.login, and that will give us back user fact and profile. I want to destructure that. So user fact, which I want to relabel as user. No. There we go. So I call it user. Okay, but we're waiting and we're inside of a non-asynchronous method. So here's a nice little trick I like to use. We're going to define an async function like so. Then we're going to take a look at the error. No, not console error. Catch. Oh, we're going to call the async function. That's going to give us back a promise, and that promise has a catch. So then I do a catch error, and then I do a console.error err. All right, now I can call my async function, and I've got my user fact coming back. It's at this point now that I can actually hold on to that user fact. How am I going to hold on to that user fact? Well, I could just stuff it into a variable. But there's a problem with that. The problem is that would be mutation. That would mutate the channel message component. And there's another problem, and that is that that other components are going to need the user as well. So what would probably be better is to do this login one level up. Maybe I should do this login from the app. Makes sense. You log into the app, and then you've got all of your stuff. So let's go ahead and change the app. Turn this into a component. Or something else I can do is not even render the app until the user is logged in. You know what? I kind of like this one. I kind of like it this way. So here's what I'm going to do. I'm going to grab all this. Okay. So I'm just going to run that when you first get started. Then, boom. Okay, I need to know where my J is. My J comes from Jinaga config, because now I am in the client. So /. So I'm logging in, and then I'm setting up the user fact. And it's here that I can put that fact in context. So if I do a context, that's a Mocha context. You know, I'll just do it the hard way for right now, and then we can research doing the easy way later. So user equals user. So in comes the user. Okay, so app is saying, hey, I don't take a user. Well, you know what? Now you do. User control. Come on, control. All right. Import statements from out shared model user. I'm going to grab user. There we go. Oh, right. That's not the syntax there. The syntax is a little bit clunky. Okay, so here is the type. The type is an object that has a user field of type user, and here is the destructuring. So that's an instance. Even though they both have brackets, they're not the same thing. I could declare this type externally, and then it's a little bit more clear what's happening. So let me go ahead and do that. No. Okay. I was trying to be clever. Never try to be clever. All right, app props is what I shall call this. So export type app props, and that's equal to this guy. See, that's fully spelled out. What's really happening is I've got app props coming in. So this is just an instance of app props, and I'm destructuring. So that means user is of type user, and I can pass that on through. User, pass that in, and saying, you know what, channel message doesn't take a user. Let's go on down and change my channel message props to take a user. And that comes from out shared model user. Perfect. Rearrange. That was Alt-Shift-O to rearrange stuff. And then when I'm finally down here, that means now I have access to the user, which means, whoa, all the way down here. Okay. When I'm sending a message, that's when I can send the sender this props dot user. Phew. Okay. I think I want to make that part of the starter kit because yeah, that's usually the way that you're going to do things. In fact, even better, what I want to make part of the starter kit is putting the user into the context, so you can just grab the user from context anytime you need it. But we're not finished here. Now we need the text. That is this.state.message text. Okay, all of that going on. And let's make this a little bit more clear what's happening. We are creating a new message. Oh, I've already destructured the message text, so I can just do that. Yeah. Although, you know what? That's balanced. Getting some things from props, getting some things from state. Now that I've sent the message, actually, I haven't sent the message yet because this returns a promise. See, promise. So once I actually have sent the message, I don't actually care about the result, so I'm going to use underscore. Then at that point, I'm going to this.set state, which means here I'm going to send in a channel message state. That's this.state. I'm going to destructure that, or not destructure, I'm going to spread that. So all of the fields in this .state happen here. And then replace the field message text with an empty string. So after we have confirmation that the fact has been saved, we clear out the user's text. We don't do that until we've got the confirmation back. If an error happens, that won't ever happen. While we're still sending, you'll still see the text there. So honor the user's input. Don't destroy it until you've saved it. So all that's good. Now we should show up the text there. We should add the message. All right. Ah, yes, one final thing. What we're getting back here, this W, this is a watch. I want to take this watch of message and empty object, and I want to save that. So now I am setting up a field that I'm stuffing something into. So this is going to be a watch, which I'm going to auto import from Jinaga, of message empty object, because that's what it was just called there. In fact, I'm going to be very explicit about this. It's going to be message watch. Right? So then we can say message watch is that this.message watch. Thank you very much, Typescript or Visual Studio Code or whoever put that this in front of there. I appreciate it. That's what happens when the component did mount. That way, when the component will unmount, I need to do this.messageWatch.stop. Stop. So this will stop watching for any new messages happening inside this channel. And so if I tear this component down, bring up a new component looking at a different channel, I'm not going to get a whole bunch of chatter. I will stop listening for messages. Okay, all of that seems to be green. And if I take a look at the internet chat app message, here's the browser remembering when we did this last time. It's I can't type my message. I cannot type anything. Why can I not type anything? Oh, look, React is telling me why I can't type anything. You provided a value prop without an onChange handler. Silly, silly me. Here's value, here's onChange. So whenever you change, here's my new change event. I'm going to do this dot set message text, and I want to get e dot. It's going to be target. E dot target is the control itself, and then from that target I can grab, wow, all this stuff. All of this stuff. Well, the thing that I want to get is the value. So here's value. Okay. All right, so that comes in as a string. Very good. So set message text. Let's put this here. Private. Set message text. Message text. Coming as a string, which means now I can do this dot set state. First of all, let's destructure this dot state, not destructure, spread this dot state. Then we're going to replace the message text with the message text coming in. Good, good. I don't know why I just hit F5. Didn't mean to hit F5. I mean to hit F5 here. Let's reload that. All right, onChange. Why are we not seeing onChange? Input text, message text. Maybe I'm not being patient. All right, refresh again. Okay, now their message is gone. So, it's Groundhog Day. Boom! It's Groundhog Day. You saw the whole page refresh, though. That's not what I want. I don't want a whole page refresh. I want it to not actually do what the form does. So here we go. On submit, we're actually getting, I have no idea what it was just doing there. We're actually getting an E, so I can say E dot prevent defaults. There we go. So send the message, prevent the default, don't refresh the page. Okay, save that. Now what's happening down here? Address in use. Okay. Oh, yeah, that's because I tried to start the debugger because I hit F5. I didn't mean to hit F5. Please forgive me. Okay, refresh. I still have my It's Groundhog Day. Message persisted. And no page refresh. It just adds it to the list, clears out the text. Excellent. We have some yaka going on. But I have a user. I want to know who the user is that posted that message. So can you please tell me, who is this user? Who has posted this wonderful message? Which means that I need to capture the user's name and then record that in such a way that I can show that on the message. So first of all, let's do the capturing of the username. So here we are all the way out here. I've done the login. now I want to do the username capture. Now, I used to have some code, but I deleted that code that captured the username. But fortunately, we can recreate that. So we've got our names. We're going to await j.query. We're going to start from the user, and we're going to query for username, which I need to bring in, dot for user. So I query for those names, and now I've got my username objects. And so if names.length is not equal to 1, or names, so it is equal to 1 and names 0, the only one in that array, that value is not equal to the profile. Where's the profile? Profile. It's not equal to profile.displayName. Then I need to record a brand new name fact. So I say await j.fact new username. What's the user? That one. What's the name? Profile.displayName. What's the prior? Names. Okay? So if I've got 0 priors, I'll do this. If I've got more than 1 prior, I'll do this, which will bring it back down to having just 1. If I have 1 prior, but it's a different name, I'll do this, which will keep it at 1, but will give me the correct name now. So that, when you log in, set your name. All that's good. But what I really want to do is, I really want to look up the user's name inside of the channel message component. So that means right here, when I watch, I need to go one step further. I need to watch the next level down. So what does that mean? I'm going to do this dot message watch, and now here I can watch one more level. I will watch j.for, and I'm going to get the message dot sender. Okay, so what is message dot sender? Well, if I look at message, sender is a field, but message.sender needs to be a static thing. I really need a template function. So I'm going to create a static sender for this particular message. And here I want to return j.match. What is the template for this thing? Well, it is strictly m.sender. Okay. So that exact fact right there is the only one that matches this template. Now, in order to be sure that we know that we've got a sender property here, I'm going to say nem dot has sender. So this is only necessary because the object that's coming in here is not an actual message object, because I don't have any messages when I'm compiling this query. I'm sending in a proxy. And so this is saying, hey, I'm about to call .sender on this thing. Make sure that it doesn't crash when it does so. That's all that's saying. So it's just a little JavaScript idiom because we don't have anything like Ruby's I forget what they call it in Ruby, but method mything. Yes, we don't have Ruby method mything. So that's the equivalent of method missing. Okay, so that means here I can watch for message sender, and then when I see one, I can record the sender's name. So I have result added will be some parent object, some parent thing, and then the result, which is the user. Well, I'm not interested in the user. I'm interested in the user's name. So that means I can say, and then I'm looking for user name dot for user. Okay. Now this callback is going to get the username. Okay. So we have a message that matched that previous watch. Now we're going to watch for the sender of that message. There's only one. And then the usernames for that sender. And once I've got it, then I can do something with it. I'm going to do something on the parent, whatever that parent happens to be. And so what I'm really going to do here is rather than add the message to, there we go, to the messages collection, I'm going to add a message view model. Okay? What do I mean by that? So here I'm going to say, let's add a message view model. I'll actually create a type for it. Message view model for this message. Am I gonna, no, I'm not gonna create a, I'm not gonna do that. I am going to do it this way. Message is going to be that actual message, and then the user name is going to be empty. Okay, so this is what I'll have in there. What's going on there? Let's start with the type. So the type, rather than an array of messages, let's make this an array of message view model. What's a message view model? Message view model is equal to something that has a message, and it has a username, which is a string. Okay. 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 So now when I add message, what I want to do is return that message view model. So let's do this, put that view model in there. So we want to return that view model. And now look what happened. Now look what happened. Well, first of all, I don't have message.text anymore. I've got message.message.text. That's a little weird. We'll think about that. We'll think about what we want to do there. But what just happened here is watch for all of this stuff. Okay. What does this look like now? It looks like result added to parent is still an empty object. Add message is returning a message view model. So what I would expect is, oh, okay, yeah. Message watch. See, what we're doing is we're watching, we're getting a we really should be getting back, here it is, a message view model. All right. So now watch gives us back a message view model because that's the type that we're getting back here. So message watch is that type. And now Control-Shift space. Okay, result added. The parent is a message view model, and the result is username. Okay? Okay. So that means that I want to set the name on that particular message view model inside of the array. How am I going to do that? So we're going to say here's the parent, the view model, and here is the message. It's the username, and I'm going to call this dot. Let's spell it out. View model message view model. Specifically what we're talking about. Username is specifically what we're talking about. So here we do set username message view model username. Okay, and we need that guy, so let's go ahead and set him up. Set. Let's see. This comes after add message, so we add the message, and then we go private set username. This gives us a message view model. And a username. Okay. So I'm setting some state, so I need to do this dot set state. And I'm starting all the way up at the top. This dot state. Spread that, and then I've got my messages, and I'm going to modify something inside of messages. Well, I'm not going to modify it. I'm going to produce another array that has all the same objects except this one message view model here. It's going to have a different username associated with it. So we are going to take all of this.state.messages, and we're going to map them and so if the message that we're talking about here, now we're inside of, let me go ahead and make this code so that it's a little bit easier to comprehend what's going on. Okay. So by default, we'll just return the message. So mapping the message to itself, that just produces the same array. So we're fine there. But if the message coming in, that message view model coming in, if its message is equal to the message view model message, if they're the same fact, and I think this will work, we're about to find out. Then I'm going to return a message view model that is spread from this message view model and the username that's coming in there. Let's see, this is supposed to be a whoa, okay. Let's see if we can reason through it before trying to read that. Okay, so what is message? What is message? Message is a message view model, right? Message view model that has the message, yeah. Calling all these things message is really confusing me. So let's start back up here and see if I can fix this one at a time. So these are view message view models. will be very verbose. That's what this is, message view models. The message text, channel message state, right, okay, message text is the user entering brand new text, so that's fine, that stays. So, message view model, empty models, plural, okay. Message view models starts out as an empty array. Okay, so then I add a message, and that gives me back a message view model. Well, it should. Here's my view model. Let's make sure that we know this is a message view model. Okay? Help me out if I've messed anything up. In fact, let's be explicit here, message view model. Okay, so set the state to message view models with this message view model. Okay, that's all good. So that gives me back a message view model. Now up here, message view model, so watch. It's giving me back a watch of message to message view model, and that's what that is. So then when I do this, I've got my message view model. Here's my username, set the username, this message view model, that username. Okay? Set username, message view model, username, the entire fact. So setting the state message view models is equal to this state message view models map message. So this is where I'm starting to confuse myself. View model is what that is. That is a message view model. So looking in that message view model to see if there's a message. Okay. So this is the affected message view model. Let's be extremely verbose about it. Affected message view model. So this is the one that the queries just hit a result on. So if this message view model message is equal to the affected message view model, boom, it's message. Then I'm going to return this message view model with the username. Okay, right. Username is a string. So I really want username dot value. That was my problem. That was my problem. All this verbosity didn't help me to fix that problem. The problem was this is a fact, and that is a string. Okay? So, else I'm going to return the message view model itself. Okay. So, all this is saying that I'm going to basically copy the state with everything the same except for the message that was just affected, that one right there. It's going to have its username replaced. And we're about to see if this triple equals actually works for these facts. Because I'm kind of on the fence about that, whether that should work or not. I mean, it would be nice if it did, wouldn't it? Okay, so now we have set the username. So whenever we chain our watches together like this, we do an additional watch after this one. When we stop the root of the chain, it stops everything. So we just have to worry about this one stop. We don't have to take this watch and further stop that one. But the upshot of all that is that inside of my list item here, I've got my message text. I should also be able to show the sender. Yeah, and this is where I'm starting to get confused here. Message view model is what's coming out of this. So there's my message view model, message text. And let's just let's do this. Let's do this upright. So here I'm going to have a span. It's going to be that. And I'll have another span, which is going to be message view model dot username. So that's a string. Yep, that's the username string. So that means as our query runs, that string gets populated, and I should be able to see those things side by side. Let's refresh, and not seeing them there. Which is probably telling me, it's probably because this equals is not working the way that I thought it would. So let's just do if the message text is the same. Okay, it's just go with me on this for a second. Very interesting. Maybe that wasn't the problem. Let's check our debug. Oh, look, we've got some problems here. Okay. Each child in the iteration have a unique key property. Okay, that's... Thank you. I really should do that. And you know what? This is actually going to help me solve my bigger problem. Let's just do what I really should have done in the first place. So, add a message. All right, I want to capture this message within the message view model. So what if I had a key property on message view model? Let's suppose it was a string. Let's suppose that I want to generate a random character sequence and use that as the key. Why not? That or actually we'll just do math.random. Okay. So you are going to be just a random number. That's what your key is going to be. We don't even need to turn it into a string. Okay, so that should be part of the message view model. Key is a number. Okay, so when we create a brand new message view model, we assign it a key. Okay, and then we put it in there. Then when we're looking for the matching message view model, we're going to match based on the key, not the message, the key. And that's how we know that we found this one. And we can then also use that here for this list item. Key equals message view model dot key. Okay. Cannot read property key of null. All right. Why are we having trouble with Yeah, it is not giving us any help either. This is just the minified Jinaga code. So, interesting. I'm out of water. Okay, so I'm going to watch for messages in channel. I add this message. I get the key. I return it. I'm guessing that this affected message view model is not being set. Let's see. So if affected message view model, then we do all that stuff. So just with that check, that should make that problem go away. It still won't show my username. Right. And that is indeed telling me that we have a problem. That affected message view model is not coming in as I expected it to. So why is that? Set username. You're called here. It should be the result of this. Let's just make sure. Let's just make absolutely sure. Let's do const w equals this watch. W is a message empty. It's not a message of message view model. Interesting. So the results. Oh, okay. That's because this signature expects result to be void, whereas this signature now this is expecting the result to have some return value. And now W is coming back a watch of message view model. Okay. So that means I can assign that to message watch. Everything's good. What is this second function? Well, if a message is ever redacted for some reason, that's the function that gets called. So that should remove the message from the list. We don't yet have a way to remove a message in the user interface, so I'm not going to worry about calling that. Now, let's refresh. And boom! All right, there's the username attached to each of the messages. This is good. This is good. This is actually starting to work. So let's hit Control-Shift-N. Start a brand new window. Localhost 8080. I'm going to sign in with Twitter. And I'm going to use a different Twitter account altogether. I'm going to use QED code. Right, and what is my password for QED code? I will look up my Twitter password, which I think is the same one that I used for QED code. Maybe? No, it did not. What I'm trying to do is if I log in as a different user, you know what? I can use Jenny's account for this. Don't tell her. All right, here's Jenny's account. I'm gonna copy that password. J Perry. My scrapper. Paste that in. There we go. So, yeah, she's going to authorize And now, boom, we are signed in. We can still see Michael L. Perry, and she can say, hi. Oh, here's Jennifer Perry coming in as hi. Oh, it actually has her name. It's not the username. Interesting. So when I'm over here, when I hit refresh, boom, I'm seeing Jennifer Perry's stuff. So I'm not seeing it show up in real time. That would be really sweet if I could see it in real time, but I am seeing the usernames of the various people that are logging in. And that's possible because I'm taking their username from their login, turning that into a fact, and then putting that into the model. That way other people can query that model and put it onto the view model and display it. So we have created a really sweet application. So we've got one step closer now to yet another chat application. We are authorizing users. Of course, we're authorizing them with Twitter, which is kind of strange because this is a chat app and it kind of takes the place of Twitter. But that aside, that little strangeness aside, we are authorizing them. We are grabbing some information about their account, and we're putting that into the model. And so we have a chat app. Yeah. Next, I do want to make it update in real time, but you know what? Unfortunately, we don't have time for that because Groundhog Day is coming to an end. And you know what that means? You know what that means? It means that we have to come over here to psql host localhost user Postgres Yaka. Actually, I didn't want Yaka. I want to connect to Postgres. And I want to drop database Yaka. And it's not going to let me drop the database because the server is running. There's a session. Oh, no, it's not. Hey, you know what? Now I'm seeing, wow, I'm seeing, oh, okay, 2 rows. Yes, there we go. Yes, because now there are 2 users. Perfect. But, all right, now drop database Yaka. Database dropped. Oh, stop. Oh, stop. And now we are m-rf Yaka. And goodbye. Goodbye. Oh, I was doing all that inside of the Jinaga folder. That's why it was shown. Anyway. Wow. Okay. But Groundhog Day has come to an end. We've deleted our code. We've deleted our data. Everything that we just did is for naught. It does not exist anymore. Oh, wait, except I have captured what I've learned from this. I will make things better because of that. And we've captured this video. And I can go back and watch the video and see where I've struggled. And that is the whole point of Groundhog Day. On real Groundhog Day. Thank you for watching, and I'll see you next time.